All right, let's just dive right into this explainer. Today we're unpacking a really fantastic guide from INFOGUIDE NG all about optimizing your off-grid cooling without completely breaking the bank. I mean, if you rely on solar power, you already know the absolute struggle of keeping your perishables safe and, avoiding a freezer full of melted ice cream without totally draining your battery bank overnight.
Because here's the thing, standard AC refrigerators put a massive energy drain on solar setups. They just aren't built for off-grid life. But on the flip side, going out and buying a brand new commercial DC freezer? Incredibly expensive. So you're stuck between a rock and a hard place, right? You either suffer with high energy costs and a dead battery, or you make a massive upfront investment. To solve this dilemma, we are going to look at 1. Why you should convert to DC. 2. The conversion process explained. 3. Some critical technical precautions to keep in mind. And 4. A few practical alternatives to conversion.
So part 1, why convert to DC? The off-grid cooling dilemma. Before we get into the weeds of the technical stuff, let's look at the tangible benefits of making the switch. When you look at the source material, there's just a night and day difference between the sluggishness of traditional AC units and the superior performance of DC setups when they're running on solar. AC compressors give you standard cooling speed, sure, but they are wildly inefficient for solar power. That's what leads to that sheer panic of a rapid power drain when the sun goes down. DC compressors, though, they boast a much faster cooling rate and are highly efficient for off-grid applications. It's basically no contest.
So, the golden workaround here is a DC compressor conversion. This is the cost-effective process of swapping your existing AC refrigerator compressor for a direct current alternative to really maximize that solar power efficiency. And this perfectly illustrates why, especially for those big commercial freezers running on solar, converting the unit is way more advisable than just buying a whole new DC freezer. You get all that incredible efficiency without the massive price tag of a brand new appliance.
Moving right along to part 2, the conversion process explained. This is essentially a mechanical heart transplant for your fridge.
According to the INFOGUIDE NG guide, the core technical work comes down to a few primary steps. First, you absolutely have to match the specific wattage and liter rating of your existing fridge to pick the correct DC compressor. Next is the welding. You need to accurately weld the discharge and suction pipes to the corresponding ones on the new unit. And finally, and the guide highly recommends this, buy the compressor yourself, but hire a professional technician to actually assist with the installation. You want to make sure everything is sealed flawlessly. Because, as the guide emphasizes here, the core of the conversion involves a very simple technical work of removing the existing AC compressor and replacing it with a DC compressor. So, while the mechanical concept of swapping the compressor is pretty straightforward in theory, executing it properly, especially getting that pipe welding absolutely perfect, is what saves you the immense cost of buying a whole new unit.
Which brings us to part 3, critical technical precautions. Welcome to the danger zone. It is time for a quick reality check, because we really need to talk about the high-stakes risks involved in the electrical phase.
Because it's not all just swapping pipes. The biggest risk here? Absolute motherboard destruction. You need extreme caution specifically when connecting cables to the electronic driver attached to that brand new DC compressor.
Let's break down exactly what that means. A single minor mistake here can be literally catastrophic. If the cable ports touch even for a split second, they'll cause a spark. That spark will instantly burn the driver motherboard. And here's the real kicker. These driver motherboards are incredibly difficult to repair once they're fried. One tiny spark from a crossed wire will destroy the motherboard, which is exactly why hiring an experienced tech for this specific step is so highly recommended by the source. You definitely don't want to fry your new investment on day one.
Okay, part 4, alternatives to conversion. The pragmatic choice. Now, if the risk of blowing a motherboard sounds like way too much technical stress for you, let's explore your practical alternatives.
Based on the INFOGUIDE NG article, you basically have 3 pragmatic paths forward. You can brave the compressor conversion, which is cost-effective and highly efficient, but it comes with that risk of motherboard damage and requires professional welding. Or you can just install a solar inverter to power your existing AC freezer. This entirely avoids modifying the fridge, but your AC unit remains much less efficient. Finally, you can just bite the bullet and buy a brand new dedicated DC solar fridge. Easiest method, absolutely zero DIY stress, but it carries a highly expensive upfront cost.
So, what does this all mean for you? The big question you have to ask yourself is this: do you have the appetite
and the steady hands for a fridge heart transplant? Or is a solar inverter just the safer bet for your off-grid setup? You've got to take a good, hard look at your budget, be honest about your technical expertise, and evaluate your actual cooling needs. Which path to off-grid efficiency makes the most sense for your solar journey?